Welcome to Homework Lib.
Hi, over here we're going to calculate the percent of ionization of a solution which is going to have a 2.50 molar concentration of HNO2, which has a Ka equal to 4.6 times 10 to the minus 4. So over here, the reaction that we're considering is HNO2 plus water, which would produce H2O plus NO2 minus. We're going to say that we have an initial concentration on our ice table of C0, which is going to be equal to the 2.50 molar that is given to us in the problem. Water is not going to enter equilibrium, and initially we're going to have 0 for each of the components. We're going to have a change of minus x, and plus x respectively, multiplying the fraction that is going to get ionized by the stoichiometric coefficient, and thus at equilibrium we're going to get C0 minus x, and x. So what we want to do is to solve for the value for x in this equation. So in this case, we're going to have the Ka is going to be equal to the equilibrium concentration of H2 plus times the concentration of NO2 minus divided by the concentration of HNO2. Remember that water is not going to enter since it is going to be a condensed phase and its activity is defined as 1. So this is going to get equal to x squared divided by c0 minus x after replacing values that were given here. And at the same time, this should be equal to 4.6 times 10 to the minus 4. So over here we have two options. Option 1 is going to be to make the approximation of a small x, which is going to give us an approximate value for the percent of ionization. In this case, the approximation is going to be is probably going to be good enough if we keep our result up to two significant digits. So let's verify what is the result that we are going to find through this small x approximation. Under this approximation, c0 minus x is going to be approximately equal to the value for c0. So, and it is usually going to work well for x approximately less or equal than 5% of the value for c0. So we're going to verify that at the end. So with this approximation, the value for Ka is approximated as x squared divided by c0. Thus, the value for x would be equal to the square root of Ka times c0, giving us a value of 0.03406 molar. And this is going to be the value for x, meaning that the percent of ionization is the total number of ions produced divided by the total number of molecules. In this case, it would be x divided by c0 multiplied by 100. So this would be 0.03406 divided by 2.5 times 100, giving us a 1.3624%, which we can round up as 1.36% directly. This is going to be a nice approximation, and actually the result is going to be quite accurate, as you're going to see in a moment. The second option is going to be to solve the quadratic expression, which is going to give us Ka times C0 minus Ka times x is going to be equal to x squared. We're going to pass everything to one side, so kx squared plus kax minus Ka times C0 should be equal to 0. We're going to solve for the two solutions, either using your calculator or the general formula that x12 would be equal to minus b plus minus square root of b squared minus 4 times AC divided by 2A, where the value for A would be equal to 1, B would be equal to Ka, and C would be equal to minus Ka times the initial concentration. So doing so, we're going to find that the value for x1, we're going to have a negative solution, which is going to be unphysical, 14, and a positive solution that is going to be the correct one, 0.000336824. And using this value for x2, what we're going to find is that the percent of ionization would be equal to 1.35%. So solving this quadratic expression is going to give us a more accurate result. This is with no approximations at all, but as you can see, the results do not differ that much. They differ by 0.01%. And with that, it would be all. In this case, I encourage you to follow the method that you're reviewing right now in class. So for example, if you're solving the quadratic expressions in your course, by all means, do it by this method. And if you're just starting to see the small x approximation and you haven't gotten into solving the exact problem, then go with the first approach. Oh, over here, I just realized for some reason I wrote down quadratic with C. Sorry about that. Nevertheless, that would be all. Thank you very much and have a good one.